Kirchhoff's circuit law lies at the heart of circuit analysis. This law analyzes how the current and voltage sources work in the electric circuit. And this law is used to calculate the unknown values of current and voltages in the circuit. Also, it helped in analysis and calculation of complex circuits that becomes manageable and easy. The Wheatstone bridge is an essential application of Kirchhoff's law. It is also used in mesh and node analysis. And in this video, we will discuss the Kirchhoff's current and voltage law and how to employ them in a circuit analysis. What's in it for you are: first, history about Gustav Robert Kirchhoff, and next, what are Kirchhoff's law, then Kirchhoff's first law or Kirchhoff's current law, after which Kirchhoff's second law or Kirchhoff's voltage law, then applications of Kirchhoff's law, and next up the advantages of Kirchhoff's law, next the limitations of Kirchhoff's law, and finally the Kirchhoff's law solved examples. Gustav Robert Kirchhoff is a German physicist who was born on March 12, 1824 in Königsberg, Prussia. His first research topic was conduction of electricity, and this research led to formulate the laws of closed electric circuit in 1845. These laws were eventually named after Kirchhoff and are now known as Kirchhoff's voltage law and Kirchhoff's current law. Since these laws are applied to all electrical circuits, and understanding their fundamental is the paramount in understanding how electronic circuits functions. Although these laws have immortalized Kirchhoff in electrical engineering, he has additional discoveries. He was the first person to verify that an electrical impulse traveled at the speed of light. Furthermore, Kirchhoff made a major contribution to the study of spectroscopy, and he advanced the research into blackbody radiation. Now let's see what are Kirchhoff's laws. In 1845, a German physicist Gustav Kirchhoff developed a pair of laws that deal with conservation of current and energy within electrical circuits. These two laws are commonly known as Kirchhoff's voltage and current law. And these laws helps to calculate the electrical resistance of a complex network or impedance in case of AC and the current flow in different network streams. Now let us look at what these laws state. Kirchhoff's current law goes by several names. Kirchhoff's current law is Kirchhoff's first law or Kirchhoff's junction rule. According to the junction rule, in an electric circuit, the total current in a junction is equal to the sum of currents outside the junction. And Kirchhoff's voltage law is also known as Kirchhoff's second law or Kirchhoff's loop rule. According to the loop rule, the sum of voltages around the closed electric circuit is 0. Now let's see the Kirchhoff's first law in detail. Kirchhoff's first law goes by several names as Kirchhoff's current law, Kirchhoff's junction rule, Kirchhoff's point rule, and Kirchhoff's nodal rule. Kirchhoff's first law is based on the conservation of electric charge because the sum of current entering into the junction is equal to the sum of current leaving the junction. We can also say that the algebraic sum of every current entering and leaving the node has to be null. This property of Kirchhoff's law is commonly called as conservation of charge, and it can be given as I exit plus I enter equals 0, or we can say I in plus I out is equal to 0. There is no charge is lost within the node. In this figure, the current I1, I2 and I3 entering the node is considered positive. Likewise, the current I4 and I5 exiting the nodes is considered negative in values. And this can be expressed in the form of an equation, that is I1 plus I2 plus I3 minus I4 minus I5 equals 0. Mathematically, Kirchhoff's current law can be stated as IK, where summation k equals 1 to n, which is equal to 0, where n is the total number of branches carrying current towards or away from the node. A node refers to a junction connecting two or more current carrying roots like cables or other components. Kirchhoff's current law can also be used to analyze the parallel circuits. Next, we will see the Kirchhoff's second law. Kirchhoff's second law is also known as Kirchhoff's loop rule or Kirchhoff's voltage law. According to loop rule, the sum of all voltages around a closed loop in any circuit must be equal to 0. It states that the net electromotive force around the closed circuit loop is equal to the sum of potential drop around the loop. And it states that the algebraic sum of every voltage in the loop has to be equal to 0, and this property of Kirchhoff's law is called conservation of energy. When you begin at any point of the loop and continue in the same direction, note the voltage drops in all the negative or positive directions, and it returns to the same point. And it is essential to maintain the direction either in counterclockwise or clockwise, otherwise the final voltage value will not be 0. The voltage law can also be applied in analyzing the circuits in series. When AC circuits or DC circuits are analyzed based on the Kirchhoff circuit law, you need to be clear with all the terminologies and definitions that describe the circuit components like paths, nodes, meshes and loops. We will discuss all the terminologies and definitions about the circuit components in next video. Kirchhoff's second law is an outcome of an electrostatic field that is conservative. Because if a charge moves around a closed loop in a circuit, it must gain as much energy as it loses. It can be summarized as the gain in energy by charge equals the corresponding losses through resistances. Mathematically, the total voltage in the closed loop of a circuit is expressed as summation B equals 0. Now let's see the applications of Kirchhoff's law. They can be used to analyze any electrical circuit, also used in computation of current and voltages of complex circuits. Next, the advantages of Kirchhoff's law. Firstly, unknown voltage and current calculation becomes easier. Next, the simplification and analysis of complex closed loop circuits becomes manageable. Next, the limitations of Kirchhoff's law. And this law is applicable when there is an absence of fluctuating magnetic field. This means in the presence of fluctuating magnetic field, we cannot apply this law. Now let's see some examples on Kirchhoff's law. And here's an example for Kirchhoff's current law to calculate the current I1 and I2. First, we need to identify the different nodes in the circuit, and here we have node A and node B. If set of currents meet at a junction, then Kirchhoff's junction rule can be expressed algebraically by assigning positive sign to each current depending on whether they are entering or leaving the junction. By convention, currents entering a junction gets positive sign and those leaving gets negative sign. Here we assume the current entering the node is positive and leaving gets negative sign. So 2A minus I1 equals 0. On taking I1 on the right side, we get the I1 value as 2A. Now we apply the Kirchhoff's current law at node B so that we get the equation I1 plus I2 equals 0. That is, the sum of currents meeting at a junction of a circuit must always be 0. We already know the value of I1. Substitute the value of I1 in the equation 2 so that we get the I2 as minus 2A. Next, let's see an example on Kirchhoff's voltage law. And this is a circuit need to be solved. The first and foremost step is to draw a closed loop to a circuit. And once this is done, then draw the direction of flow of the current. And next step is to define our sign conventions. On applying the Kirchhoff's first law at B and A, we get I1 plus I2 equals I3. By making use of the above convention and Kirchhoff's second law, from the loop 1 we have 10 equals R1 into I1 plus R2 into I3. On substituting the values of R1 and R2, we get the equation 1. Now taking the loop 2, R2 into I1 plus R3 into I3 equals 20. On substituting the values of R2 and R3 in the equation, we get I2 plus 2I3 equals 1. Now considering the loop 3, we get 10 minus 20 equals 10 I1 minus 20 I2. On resolving this, we get the equation 3. There is minus I1 plus 2 I2 equals 1. Now we have three equations from loop 1, loop 2 and loop 3. Making use of the Kirchhoff's first law, we get I3 value as I1 plus I2. Now take the loop 1 and we have the equation I1 plus 4I3 equals 1. Now substitute the value of I3, that is I3 equals I1 plus I2 in the equation 1, so that we get 5I1 plus 4I2 equals 1. Now taking the loop 2 equation, and here also we are substituting the value of I3, that is I3 equals I1 plus I2. So the equation 2 gets reduced to 2I1 plus 3I2 equals 1. Now comparing the equation 4 and 5, we get the I1 value, that is I1 equals minus 1 by 3 I2. Now substitute the I1 value in the equation 3. On simplifying this, we get the I2 value, that is I2 equals 0.4285. Now substitute I1 and I3 in KCL equation. On that we get I3, that is I3 equals 0.286. Now we know the value of I1 and I2. Now substitute these values in KCL so that we get the I1 value. So from these equations we get the I1, I2 and I3 values. And that's all for this session. Thank you so much for watching.